Hello, and welcome to our ELECOMP Summer 2024 Virtual Summit. We are Team RDSI, and the purpose of this presentation is to inform you about our project, the Critical Data Relay, which is an aggregation of data from first responders to a Windows API display. To begin, I would like to introduce our esteemed technical directors. In order of appearance from left to right, we have Jamie Gagnon, our consulting technical director, responsible for providing us with the technical background help that has made this project possible. Next, I would like to introduce Hannah Morrissey, a recent graduate from this ELECOMP Capstone program, now working for RDSI as an electrical engineer. And finally, I would like to introduce Bruce Torman, mechanical engineer and engineering manager at RDSI. Now, let's meet the team. Team RDSI is composed of two team members, Juan Cante, studying computer engineering, and myself, Eric Slater, also studying computer engineering. Before we dive into the project, we would like to take a moment to also provide an overview of the sponsor company, RDSI, which stands for Research and Development Solutions Incorporated, headquartered in Pawcatuck, Connecticut. RDSI is a service-disabled veteran-owned small business that performs a wide range of engineering, technical, and programmatic functions in supporting various government and commercial clients and specializes in delivering affordable, scaled, state-of-the-art solutions to government and industry clientele. The RDSI Department of Defense portfolio includes expertise in the areas of submarine imaging, electronic warfare, and weaponry, to name a few. In support of public safety projects and clientele, RDSI has strong connections with the local public safety efforts, such as the Rhode Island Office of the State Fire Marshal. The motivation behind this project is to modernize the current firefighter experience when it comes to referencing hazard response information for chemical spills. The Emergency Response Guidebook, where this information is available, is comprised of three main sections: a yellow and blue section for indexing chemicals, either by name or chemical ID number, orange pages which contains chemical hazard response information, including potential hazards, public safety guidance, and emergency response instructions, and finally, the green pages which contains evacuation range tables for certain chemical spills. The current process for firefighters involves searching through the yellow pages and blue pages of the book to identify the chemical, finding the corresponding guide page in the orange section, and potentially referencing several tables for evacuation distances in the green pages, depending on the chemical. Our predecessor team, 2022 through 2023 ELECOMP team RDSI, developed a prototype proof of concept phone application for accessing information in the Emergency Response Guidebook on mobile devices. Now RDSI would like to develop, package, and produce a full first responder technical solution on a Windows device. Now that we've established the foundation for our project, I will explain the solution our team has produced. As RDSI plans on creating a packaged, ruggedized laptop loaded with the RDSI software for accessing emergency response information, we have created the first stage of this product. Our anticipated best outcome is a software application which RDSI can combine with their own source laptops to sell to first responders. This tool is loaded with a digitalized version of the Emergency Response Guidebook, with room for RDSI to add and develop their own tools to market the product to other first responders in the future. Team RDSI is proud to report that we have achieved our anticipated best outcome. Our project has met the requirement of a data display tool for the Emergency Response Guidebook, while also refining the graphic user interface for a more professional appearance, which RDSI will be able to further develop. Our team's key technical accomplishments include the desktop application created in Windows Presentation Foundation, WPF, and an accompanying SQLite database containing data from the Emergency Response Guidebook. Using WPF, chosen as a software application platform as its purpose-built for Windows desktop applications, we migrated the layout and technical accomplishments of the previous team to a Windows solution and updated the UI for use in a desktop environment. For backend development, we created a database using SQLite, which is a lightweight version of SQL, which stands for Structured Query Language, and is a programming language for storing and processing information in a relational database. This database was created by our team from the ground up, including defining the database schema and seeding the data with information from the Emergency Response Guidebook. Now, before we delve into the technical details, let's discuss the economic impact of this project. For RDSI, a successful achievement of the ABO and its planned release after further development by RDSI would result in improved relations with first responders, establishing RDSI as a tech leader for first responder solutions and innovations, fostering a strong relationship in the future between the company and local departments as RDSI opens the market to more technological products to improve first responders' safety and capabilities. Here is a simplified block diagram illustrating the flow of activity for our project. As shown, the application first guides the user to determine and identify the chemical, while the application queries a database for the information. Next, the information is accessed from the database and is displayed to the user, and the user can then decide on querying new materials or exiting the application. For my individual technical accomplishments, I have been responsible for back-end development of the application and ensuring the functionality of the SQLite database. I have designed and implemented within the SQLite schema entities for the chemical, guide, and evacuation information. Entities are objects within the database which can be accessed and processed in individually defined reference data for a chemical or response information for a guide page from the Emergency Response Guidebook. The next step to this process was filling the database with an initial set of information, otherwise known as database seeding. To create the entities used in the database, we use the datasheets for the Emergency Response Guidebook, made publicly available by the Department of Transportation, and converted the data into CSV files I could access and read with a program. The data stream from the files were then tokenized and used to populate entries in the database, which can then be used by the application to query and display information. At this point, I would like to introduce my partner for this project, Juan Cante, a fellow computer engineer major who has been as equally committed as I have to achieving our anticipated best outcome. I will now hand it over to Juan, who will discuss his work with the front-end development of the project.